Alright, Lechatellier's principle. Once a system has reached equilibrium, and that's important, it already has to be at equilibrium. Any factor which causes a change in the rate of the forward or reverse reaction will disturb or shift the equilibrium. And the system will readjust itself to a new equilibrium, and the rates will become equal again. And this, whatever stress and we'll talk about some different stresses, when a stress is applied to a system equilibrium, the system will readjust so as to relieve or offset the stress. Let's say, equilibrium systems hate change. If you try and make a change that's going to do something to them, they will attempt to undo that change. Okay? So what are some things that I can do? I can change the concentration, I could change the pressure. If they're gases, I could change the volume, or I could change the temperature. So I'll show you how to do these questions. This is what you're going to be asked to do. So I have a reaction here, and I'm going to make some changes here, and I'm going to decide if this equilibrium will shift left or right to reach a new equilibrium. So the first thing is, if I increase SO2, so if I dump some more SO2 into this reaction vessel, it will not like that, and it will want to use up that extra SO2. And if it uses up this SO2, the reaction will shift to the right to use up the SO2. If I take out, or if I decrease the pressure of SO3, so this is going down. Does this system like it? No. What's it going to do to compensate? It's going to try to make this go back up, so it will once again shift right. Temperature. So here, heat is written like this. Sometimes you'll get questions. This is exothermic, so delta H is equal to, let's say, negative 400. Who cares? Yes. If it was given like this, I suggest you write your reaction. There'd be no plus 400 kilojoules. Instead of writing it like this, like we did with Hess's law, my suggestion is that you write it like this. Okay. So if this goes down, decreases, does the system like it? No. It's going to make more. It's going to shift right again. HE gas is added at a constant volume, so the total pressure is increased. This question is a little tricky. HE, please notice, is not part of the reaction. When I add HE in, the individual pressure of this, and this will not change. Yes, the total pressure will go up, but the individual pressures will not change. This will have no change. HE gas is added, and the container is allowed to expand, so the total pressure is kept constant. So I add in a gas, the volume gets bigger. So if the volume gets bigger, this thing does not like that. The pressure in the container has, in a way, dropped. Now, how many molecules are on this side? 2, and another 1 makes 3. There's 3 on this side, and there's 2 on this side. So the pressure of these things, forget the HE, the pressure of these things has dropped. So therefore, they need to increase the pressure again. So this thing is going to shift left, because when this thing shifts left, I get 3 molecules instead of 2. 2 becomes 3, 2 becomes 3, 2 becomes 3, 2 becomes 3, and the pressure would start to go back if I add a catalyst, this thing's already at equilibrium, so this would be no change. Another one. So, system's at equilibrium. I add in some H2, it doesn't like it, this thing is going to shift left to use up that H2 we just added. If I add in some more H2O, this thing does not like that, it's going to shift right to make it go down. Concentration of O2, if this gets bigger, it's going to shift left to use it up. If I increase the temperature, so this is getting bigger, just like these other questions, I can think of it when I write the actual heat expression in the reaction. If this gets increased, it doesn't like it, it's going to shift right to use it up. And if I decrease the volume of the container, well, on this side I have 2 molecules, on this side I have 3. So if I decrease the volume, the pressure is going to go up. Does it like it? No, it does not like the fact that the pressure has gone up. It wants the pressure to go back down again. Which way will allow the pressure to go back down again? If it goes left. Because 3 will become 2, 3 will become 2, 3 will become 2, 3 will become 2, and then the pressure will go back down again. And if I add HE gas, it's a noble gas. Notice HE is not in this reaction. This would be no change. So that is a quick look and introduction to what Le Chatelier's principle is. And remember, equilibrium system